Alright, so we're going to review distance and midpoint formulas. Alright, so our distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So for number 1, let's find the distance between negative 2, 1 and 1, 5. So we've got, let's see if I can turn my pen on here. Alright, so we've got our x1, y1, x2, y2. So now let's just plug it into our formula. So d equals the square root, and we've got 1 minus a negative 2 squared plus 5 minus 1 squared. Let's simplify our radical sum. 1 minus a negative 2 is 1 plus 2. So we have 3 squared. And then 5 minus 1 is 4. So we have 4 squared. We keep simplifying. We have 9 plus 16. So our distance is the square root of 25, which simplifies nicely to 5. So the distance between negative 2, 1 and 1, 5 is 5 units. It's as easy as that. Let's try another one. So we've got the radius of a circle, given that the center is at 2, negative 3, and the point negative 1, negative 2 lies on the circle. So if we look at our graph, it's telling us that we have our center at 2, negative 3. So there's the middle of our circle. And we know that the point negative 1, negative 2 lies on our circle. It's a terrible point. So that means our circle is going to look something like that, even though it's a terrible circle. And we know our radius connects the center to that outer point. So we want to find that distance between these 2 points. So we've got it over here, x1, y1, x2, y2. So we've got the square root of negative 1 minus 2 squared plus negative 2 minus 3 squared. Minus a negative 3. There you go. Negative 2 minus a negative 3 squared. Get my parentheses. Alright, so let's simplify our radical. Negative 1 minus 2 is negative 3. So we have negative 3 squared. Negative 2 minus a negative 3 is the same as negative 2 plus 3, which is just 1 squared. So our distance is the square root of 9 plus 1, which is the square root of 10. Now, we're going to leave this in simplest radical form, and we cannot simplify the square root of 10 anymore without going into a decimal and getting rid of our radical. So our radius is just the square root of 10. Alright, let's try another one. Find the y values that make 4y 10 units from the point negative 2, 1. So if we look at our graph, we're given a point negative 2, 1, and it gives us our x value. So our x is somewhere on this vertical line at 4, or our y is going to be somewhere on this vertical line, and we want to find the values of y that make this point 10 units away from that vertical line. So we know our distance is 10, so we can go ahead and plug in our d, and then we'll have x1, y1, x2, y2. Alright, so we got the square root. So in our first parentheses, we're going to have negative 2 minus 4 squared plus 1 minus y squared. Alright, so let's simplify our radical. So we've got the square root of negative 6 squared plus 1 minus y squared. And we'll simplify down one more. We have the square root of 36 plus 1 minus y squared. So now we have a variable underneath this radical that we want to solve for. So just like our last unit, we're going to simplify by squaring to get rid of that radical. So we have 100 equals 36 plus 1 minus y squared. So let's subtract 36. So we get 64 equals 1 minus y squared. So now we're going to FOIL. So 64 equals, we have our first 1 squared, so 1 squared is 1. Then we're going to multiply them together and double it. So we get negative 1y times 2 is negative 2y. And then we'll square our last term, so we get plus y squared. Now I'm going to write this in standard form and set it all equal to 0 at one time. So we get 0 equals y squared minus 2y, and now I'm going to subtract the 64, so we get minus 63. So now here we have a nice quadratic, which means we're going to get two possible solutions, and we're going to factor it. So we want something that multiplies to get negative 63, but adds to get negative 2. So if we think about that, we should get y minus 9 times y plus 7. Set it equal to 0, so we get y equals 9 and y equals negative 7. So that means we have our two solutions, so we can put them as ordered pairs. So we have 4, 9, and 4, negative 7. So those are the 2 points on that line that will both be 10 units from our starting point, negative 2, 1. Alright, now let's look at midpoint. So our midpoint formula is a coordinate, so we have x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So let's find the midpoint between negative 1, 2, and 3, negative 6. So we have x1, y1, x2, y2. So if we go to our coordinate, we'll have negative 1 plus 3 divided by 2, and our y coordinate will be 2 plus a negative 6 divided by 2. So negative 1 plus 3 is 2, and 2 plus a negative 6, or 2 minus 6, is negative 4 over 2. So 2 divided by 2 is 1, and negative 4 divided by 2 is negative 2. So our midpoint between negative 1, 2, and 3, negative 6 is simply 1, negative 2. Alright, now let's find the value of p such that negative 2, 5/2 is the midpoint between p2 and negative 1, 3. So we know our 2 points, so we have our x1, y1, and our x2, y2, but we're missing this x coordinate, right? We know what our midpoint is, and we know our 2 points. We just got to find this x. So let's look at just this half of our midpoint formula. So we know we have x1 plus x2 over 2, and we're going to set that equal to our x coordinate of our midpoint, which is negative 2. So now let's fill in our x1 and x2. So we get p plus negative 1 over 2 equals negative 2. So we'll multiply by 2 to get rid of that denominator. So we get p, I'm going to say p minus 1 equals negative 4. Then we'll add 1, and we get p equals negative 3. So our coordinate, our p value is negative 3, which would make our coordinate negative 3, 2. Right? Pretty easy. It's all review, and we'll do a lot more of that in class tomorrow. So I'll see you in the morning.